Hello, welcome to Exam Plug, and today I'm going to go through the Bmat Section 2 from October 2018. This is the Scientific Knowledge and Applications paper of the Bmat, and it is non-calculator. Just a quick mention before I start, it'd be great if you could like the video, subscribe to the channel, and turn on post notifications. It would be a massive help. Now, without further ado, let's get straight into the questions. 1. People with cystic fibrosis may be unable to digest their food fully because of thick, sticky mucus. This prevents the secretion of pancreatic juices. Doctors sometimes prescribe enzyme supplement medication to improve digestion. Which of the following enzymes should be included in the medication? Number 1, amylase. Number 2, lipase. Number 3, protease. So, first thing you should be thinking about right now is the digestive system. And using your knowledge of the digestive system, you should be able to narrow down where these enzymes are produced. So, amylase is produced in the salivary glands and pancreas. Lipase is produced predominantly in the pancreas. And protease is also predominantly produced in the pancreas. So therefore, our answer is H. And that's question 1. 2. Question 2. Elements Q and Z are shown in the periodic table as Q and Z. What is the empirical formula and bonding type of the compounds formed between these elements? So first we need to work out the valency of Q and Z. So Q has an atomic number of 12, therefore it has 12 electrons, and we could then further deduce that Q has a valency of 2. Z has 9 electrons because its atomic number is 9, and therefore has a valency of 1. So, using this information about valency, in which Q is equal to 2 and Z is equal to 1, we could then further determine that the empirical formula is going to be QZ2. So straight away we could eliminate A, B, E, and F. Now, determining whether it's ionic or covalent. The aim of the game here is looking at Q, because Q has a valency of 2 and it looks like a group 2 metal. And group 2 metals cannot bond covalently, they could only bond ionically. So therefore, the answer is C. And that is question 2 complete. Question 3. Here are 4 statements about light. 1. In a vacuum, green light travels faster than blue light. 2. In a vacuum, the wavelength of red light is greater than the wavelength of green light. 3. In water, red light travels faster than it travels in a vacuum. 4. In water, the frequency of blue light is greater than the frequency of red light. Which pair of statements is correct? So, how we're going to solve this question is by going through each statement and eliminating incorrect statements until we're left with our final answer. So, statement 1. In a vacuum, green light travels faster than in blue light. Straight away, that is incorrect, because the speed of light in a vacuum is 3 times 10 to the 8, regardless of what color it is. Therefore, it's impossible for green light to travel faster than blue light. So every option that shows 1 is incorrect. So A, B, C. Statement number 2. In a vacuum, the wavelength of red light is greater than the wavelength of green light. Now, in order to solve this problem, you need to remember the order of wavelength in visible light. So it's first red, then it's orange, then it's yellow, then it's green, then it's blue, then it's indigo, and then it's violet. So, based off this information, this is correct, because red does have a greater wavelength than below. So all the options that contain 2 is correct, so F is eliminated. Now, statement 3. In water, red light travels faster than it does in a vacuum. So this statement is assessing your knowledge of the refractive index. Light travels more slowly in water than it does in a vacuum. Therefore, 3 is incorrect. So, that leaves you with the answer of E, and that's question 3 completed. Question 4. Which one of the following is a simplification of 48 m to the power of 5 p over 40 m to the power of 2 p to the power of 3? So straight away, I'm going to find out what 48 over 40 is simplified to. So 48 over 40 is equal to 6 over 5 because 48 and 40 are divisible by 8. So D, E, and F are straight away eliminated. Now I'm going to find out what m over m to the power of 5 over m to the power of 2 is equal to. So 5 minus 2 is 3, so that eliminates A. And finally, p over p to the power of 3 is equal to p to the minus 2. Therefore, your answer is B. Question 5. We don't need to worry about question 5 because question 5 is an incorrect question. It hasn't been written properly, so let's give that a big cross. So question 5 is an automatic mark. So moving on to question 6. Question 6. The diagram below shows the apparatus that can be used in fractional distillation. And here's a diagram of that. Which of the following statements is/are correct about the process shown in the diagram? 1. Covalent bonds between atoms are broken at position 1 and have reformed at position 3. 2. The particles are closer together at position 3 than at position 2. 3. The physical process at position 1 involves an exothermic change. So, let's look at statement 1. Covalent bonds between atoms are broken at position 1 and have reformed at position 3. At position 1, the liquids are separated according to their boiling points. However, no covalent bonds have actually been broken. The intermolecular forces have been broken down, where you have the process of boiling. And process 3 is condensation. So, therefore, 1 is incorrect. Statement number 2, the particles are closer together at position 3 than at position 2. At position 3, the substances are liquid again, whereas at position 2, it's a gas, and gases are less dense than liquids. Therefore, they are closer together, and statement 2 is correct. Statement number 3. The physical process at position 1. Statement number 3. The physical process at position 1 involves an exothermic change. Well, at position 1, heat is being applied to the liquids, and therefore it's boiling and evaporating. This is an endothermic change, not an exothermic change. Therefore, 3 is wrong. And as a result, C is the correct answer to the question. Question number 7. A wave traveling through a material has a frequency of 50 Hz and a wavelength of 0.4 meters. How long does it take for the wave to travel 100 meters through this material? So, we first need the equation V equals F lambda. So, we're working out velocity straight away. So, 50 times by 0.4 is equal to 20. So we know the velocity is 20 meters per second. Now we need to work out how long it took for the wave to travel 100 meters. So we now need to use the equation speed equals distance over time. But we need to rearrange that equation to time is equal to distance over velocity which is 100 over 20, which is equal to 5 seconds. So the answer to this question is E, and that's question 7 completed. Question 8. My wallet contains 2 50p coins and 5 20p coins only. I need 70p to buy an item. If I pick 2 coins at random from my wallet, what is the probability that I have picked the exact money to buy the item? So, we're essentially going to have to work out 2 probabilities here. First, picking up 50p and then 20p, and the second probability is picking up 20p first, then 50p. So, we know that the probability of picking up a 50p first is 2 over 7, and we multiply that by the probability of then picking up 20p, which is 5 over 6. That comes to 10 over 42. So that's the first probability that we've worked out. The second probability is first picking up a 20p, which is 5 over 7, times by the probability of then picking up the 50p, which is 2 over 6, which is 10 over 42. And we now need to add these 2 probabilities together, which is equal to 20 over 42, or 10 over 21, which is equal to C. And that is question 8 completed. Question number 9. A sample of healthy human cells contained 4 cells. After they were allowed to divide 5 times using the same type of cell division, there were 128 cells in the sample. Assuming that no mutations occurred, which of the following statements are correct? 1. All the cells would have the same number of chromosomes. 2. The cells were gametes. 3. The cells would be clones of their original cells. 4. This type of cell division is called meiosis. So straight away you know this question is asking you whether the division was meiosis or mitosis. And mitosis divides one cell into 2, and meiosis divides one cell into 4 daughter cells. And in meiosis, they are not clones of the original cells, whereas in mitosis, the daughter cells are clones of the original cell. So what I would do to keep things simple and foolproof is write out the 5 cell divisions of mitosis, because doing mitosis first would be easier. So you know that it doubles anyways. So you go 4, 8, 16, 32, 64, 1, 2, 8. And each time they're doubling for mitosis. And that's 5 times. And yeah, so straight away you know that the type of cell division occurring here is mitosis. So straight away you could get rid of number 4. So that removes F, E, and C. Now, if it is mitosis, you know that the cells would be clones of the original cells because they have the same number of chromosomes. So that means 3 is correct. So that removes A, and number 1, all the cells would have the same number of chromosomes. That is correct. So that leaves us with B. And that is question 9 completed. Question number 10. Iron is extracted from iron ore, which contains Fe2O3, using carbon monoxide. This overall reaction is slow and so must be heated. The chemical equation for this reaction under certain conditions is shown below. Fe2O3 plus 3CO goes to 2Fe plus 3CO2. and there is an enthalpy change of minus 30 kilojoules per mole. Which one of the following statements about this process is correct? So A, the ions in Fe2O3 lose electrons to become Fe. The Fe in this compound, this iron ore, has a charge of 3+. In order to become Fe, the element, it has to gain 3 electrons, not lose electrons, so therefore A is incorrect. B, the oxide ions in Fe2O3 each have a charge of minus 6. So, we know that the Fe in this compound has a charge of 3+, and there's 2 of them. So, that will give a charge of 6+, or plus 6, however you like to call it. Now, that means that there has to be a negative charge of minus 6 to balance this out. However, there are 3 oxygen atoms to do this. So, 6 divided by 3 is equal to 2. So, the charge of each oxide ion in this compound is actually minus 2. So, B is incorrect. C, the Fe2O3 acts as an oxidizing agent in this reaction. So, oxidizing agents cause another substance to lose electrons and therefore gain electrons themselves. As Fe2O3 is giving oxygen to carbon monoxide to form carbon dioxide, it is an oxidizing agent and therefore C is correct. And that is the answer to 10. Question number 11. Quantities associated with a moving vehicle include its velocity, speed, momentum, and kinetic energy. Which of these quantities will always change if the vehicle changes direction? So this question is basically asking which is a scalar, which is a vector, and we want the vectors. And straight away, you should know from GCSE physics, you don't need to work this out, is velocity and momentum. That's your answer. So the answer is E. And that's question 11 completed. Question 12. All 4 corners of a rectangle are on the circumference of a circle. The rectangle has a perimeter of 24 centimeters. The ratio of length to width for the rectangle is 3:1. What is the area of the shaded region in centimeters squared? My initial thought would be is to work out the length and the width of the rectangle and therefore work out the area of the rectangle. So, I know that a rectangle's perimeter is equal to 2 times its width plus 2 times its length, which is equal to perimeter. Now, based off this information I've just given, I now need to half the perimeter, which is 12. And with that, I can know that W is equal to L. Now, I'm going to add the ratio length to width over here, which is 3 plus 1, which is equal to 4. Then I'm going to do 12 divided by 4, which is equal to 3. So I now know the width of this rectangle. And I'm going to do 3 times 3 because of the ratio, which is equal to 9. So now I know the length. Now I can work out the area of this rectangle as a result. So 3 times 9 is equal to 27. Straight away, I could double check and look down if any of the answers don't contain 27. And some of them do. So I'm going to eliminate C, I'm going to eliminate D, I'm going to eliminate G, and I'm going to eliminate H. Now, next steps. So I've worked out the area of the rectangle. Now I need to work out the area of the whole circle. So, I know that I know the length and I know the width. So based off this information, I can form a triangle which will help me find the radius. And this is what we need to solve. And we're going to do this by using Pythagoras' theorem. So I'm going to just draw a bigger version of that triangle. And the triangle's base is going to be 1.5 because half of the width is 1.5. And the height is going to be 4.5 because half of the length is 4.5. And now using the Pythagoras' theorem, which is a squared plus b squared is equal to c squared, I'm now going to input this information in. So a squared, let's label this a, b, c, where c is the hypotenuse and in this case the radius, 1.5 squared plus 4.5 squared is equal to 81 over 4 plus 9 over 4, which is equal to 45 over 2. So we know what c squared is, so we know what the radius squared is. Now, what is the formula of working out the area of the circle? Pi r squared. So we don't even need to find out the square root of c squared because we need that radius squared anyways. So 45 over 2, which is our r, times by pi is equal to 45 over 2 pi, which is our area of our circle. And we now want to work out the shaded area of this circle. So the area of the circle minus the area of the square. So that will be 45 pi over 2 minus 27, which gives us f as the answer. And there we go. We have the solution to question 12. Question 13. The diagram shows 3 different types of animal cells. 1. Epithelial cell. 2. Mature red blood cell. 3. Muscle cell. Which of these cells is/are found as a part of a tissue? Now, thinking about it, epithelial cells form epithelial tissue, so that's easy. Straight away, you know 1 is correct, and it's going to be part of your answer. 3 as well, muscle cells. You know muscle cells are used for muscle tissue. Straight away, you know that's also correct. Now, statement number 2, is the trick of this whole question. Most people don't think of blood and red blood cells as a tissue or an organ. However, blood is a type of connective tissue, so therefore 2 is a tissue. So the answer is going to be H, where all 3 options are selected. And that is the solution to 13. Question 14. The masses of atoms and molecules can be determined using a mass spectrometer. The masses can be shown as a series of peaks. Element X exists as a diatomic molecule. The mass spectrum will show the mass of ions from individual atoms of X and from X2 molecules. The mass spectrum for element X is shown below. How many different types of isotopes of X can be determined from this spectrum? So, we're told that element X exists as a diatomic molecule. Therefore, the peaks at higher masses are likely to be that of diatomic molecules. So let's quickly just cross them out for ease sake. Now, if you look to the only set of peaks left, we're left with 2 peaks. And that is the number of different isotopes available. 2. One is 35 and the other one's 37. And that's your answer, B. That's the solution to question number 14. Question number 15. A champion weightlifter raises a 200 kg set of weights from the floor to above his head in one movement. The bar is lifted through a vertical distance of 1.8 meters. When the lift is completed, the weightlifter holds the weight stationary for 2 seconds and then drops them to the floor. At what speed do the weights hit the floor? Gravitational field strength is equal to 10 newtons per kg. So first I'm going to work out the gravitational potential energy that is given. So that is going to be potential energy is equal to mass times gravitational field strength times by height, which is equal to 200 times 10 times 1.8, which is equal to 3,600. And the potential energy is equal to the kinetic energy as the object falls. So Ke is equal to a half mv squared. So Ke is equal to 3,600. So equal to 0.5 times by the mass, which is 200, v squared. So we want to put v squared by itself. So v squared is equal to 3,600 over 0.5 times 200, which is equal to 36. And now we just want v by itself. So v is equal to 36 root of 36, which is equal to 6. So the answer is E. That's your solution to question number 15. Question number 16. The first four triangle numbers are 1 to 1, 3 to 3, 6 to 6, 10 to 10. The difference between the first and the second triangle number is 2. The difference between the second and the third triangle number is 3. The difference between the third and the fourth triangle number is 4. All the triangle numbers follow this pattern. The difference between the rth value, triangle value, and the r plus 3 triangle value is 126. What is the value of r? So, in order to calculate the value of r, we first need to work out the pattern. So set 1, there is 1 circle. Set 2, there's 3. Set 3, there's 6. Set 4, there's 10 circles. We can see from this pattern that the pattern is a set of numbers which is added onto the previous number of circles to give the number in that set. We then apply this rule for r. R is adding the set number to the previous number. For example, the rth set contains r plus n, where n is the previous number of circles. So, since the difference between the r plus 3 set and the r plus 0 set is 126, we could solve this algebraically. 4r plus 6 plus n minus r plus n is equal to 126. 3r plus 6 is equal to 126. 3r is equal to 120. R is equal to 40. And therefore B is your answer. And that's the solution to question number 16. Question number 17. The diagram shows a simple piece of apparatus that can be used to demonstrate some of the events involved in human ventilation. Which events occurring during ventilation will be demonstrated by pulling the rubber diaphragm downwards, as shown by the arrow? 1. Diaphragm relaxes. 2. Diaphragm contracts. 3. Volume of thorax increases. 4. Volume of thorax decreases. 5. Pressure in thorax increases. 6. Pressure in thorax decreases. Straight away, what stands out to me is that if you pull the rubber diaphragm, the volume of this glass container increases. So therefore, the volume of the thorax increases. So 3 is correct and 4 is incorrect. So every answer that contains 3 is a possible correct solution. So we've eliminated C, D, G, and H. Now, as a result, since the volume has increased, the pressure will decrease. So the pressure in the thorax in human ventilation will decrease. So 6 is correct. So anything that contains 6 is correct. So A is eliminated and E is eliminated. Now, looking at the diaphragm itself. The diaphragm is actually contracting, it's being pulled downward, and it's contracting and flattening out. So 2 is correct and 1 is incorrect. That means the answer is F, and that's the solution to 17. Question number 19. A circuit consists of a 10 resistor and a variable resistor connected in series with a 6-volt battery. A variable resistor has a minimum resistance of 2 and a maximum resistance of 20. What is the difference between the largest and smallest currents possible in this circuit? So we need the equation, or the formula, I should say, V equals IR. And we want to rearrange it such that I is the subject. So I is equal to V over R. And now we're going to substitute some values in. So we know the voltage is 6 and the resistance is 10 plus 2, which is 12. So the current is going to be 0.5 amps. Now, if there is the largest resistance of 20, that's going to change slightly. So we're still going to have a voltage of 6, but at the denominator, where the resistance goes, it's going to be 10 plus 20, which is 30, which is equal to a fifth, which is 0.2 amps. So therefore, the difference between the largest and smallest currents is going to be 0.3, which gives B, because 0.5 minus 0.2 is equal to 0.3. That's your answer to question number 19. Question number 20. The mean mass of a sweet in a bag of 20 sweets must be greater than 10 grams, but not greater than 10.5 grams. A bag is being filled with sweets. The mean mass of the first 16 sweets is exactly 9.5 grams. 4 more sweets, each of a mass x grams, are added to the bag to bring the mean mass of 20 sweets into the correct range. What's the complete range of possible values of x? Straight away, I would work out the total weight of this first 16 sweets. So 16 times 9.5 is 152. So 16 times 9.5 is equal to 152. Now I'd work out the minimum and maximum weight of the 20 sweets. So 20 times by 10, which is equal to 200. And 20 times by 10.5, which is equal to 210. Now I would work out the difference between 200 and 152 and 210 and 152. So 200 minus 152 is equal to 48. 210 minus 152 is equal to 58. 48 divided by 4 is equal to 12. 58 divided by 4 is equal to 14.5. So we know D, E, and F are incorrect. Now we need to go to the first line to see what the bounds are going to be. So it says the mean mass of a sweet in a bag of 20 sweets must be greater than 10 grams. So C is eliminated, but not greater than 10.5 grams. So B is eliminated, and therefore the answer of 20 is A. Question number 21. An animal cell is surrounded by a very dilute glucose solution, which has a low concentration of glucose than the glucose solution in the cytoplasm of the cell. There is net movement of glucose molecules and water into the cell. A second identical cell is treated for a short time with a chemical that inhibits respiration. The cell is then surrounded by the same glucose solution. Which row in the table shows the effect of this chemical on the movement of glucose molecules into the cell and the movement of water molecules across the cell surface membrane immediately after it is surrounded by the solution? So, straight away the answer is A, and I'll explain why. The reason for this is because glucose uptake is done by active transport, and water goes into the cell through osmosis. And the reason for this is because the water potential outside the cell, the concentration of water outside the cell is greater than the concentration of water in the cell. So the water goes down the gradient, water concentration goes down the gradient from high to low, and the water enters the cell through osmosis. In regards to glucose molecules, the cell contains a higher concentration of glucose than the dilute glucose solution. So the glucose cannot move into the cell through diffusion, but at the same time it cannot move in through active transport because there's no ATP that's being able to be produced to allow that movement. So therefore the answer is A, and that is question 21 completed. A compound of oxygen and fluorine has a relative molecular mass which is twice that of its empirical formula mass. 105 grams of the compound contains 57 grams of fluorine. What is the molecular formula of the compound? So I would straight away do 105 minus 57, which is equal to 48. And then I would form a ratio of fluorine to oxygen. Fluorine to oxygen. So I know that there is 57 fluorine, oxygen, there is 48. I divide each of them by their respective atomic weights. And then I would simplify the fractions into their ratio. So 3, 3, and that goes to 1, 1. So there's a 1-to-1 ratio of fluorine to oxygen. However, reading the question, it says that a compound of oxygen and fluorine has a relative molecular mass which is twice that of its empirical formula mass. So therefore, the answer has to be C. And that's question 22 completed. Question number 23. The radioactive isotope plutonium-244 becomes radon-220 after a succession of decays. The atomic number of plutonium is 94 and the atomic number of radon is 86. How many alpha particles and how many beta particles are emitted altogether during the decay of one nucleus of plutonium-244 and radon-220? So this question relies on your knowledge of alpha and beta decay. Alpha decay involves the loss of 2 protons and 2 neutrons, and beta decay is the loss of 1 electron. In the decay given, the mass falls by 24 and the atomic number falls by 8. So those are the numbers that you're working with. As only alpha decay causes the loss of mass, we can work out that 6 alpha decays are required to satisfy the mass element of decay, which narrows the options to A and B. So let's quickly cross them out. C and D, E are crossed out. With 6 alpha decays, the atomic number has been decreased by 12, and we need the atomic number to decrease by 8. So there must be an additional 4 beta decays. So A is cancelled, and your answer is B. And that's 23 complete. Question number 24. Which one of the following is a simplification of x over x minus 1 minus x squared plus 3 over x squared plus 2x minus 3. Straight away, we need to make a common denominator, so we could solve the numerator. So I can see straight away that x minus 1 is a factor of x squared plus 2x minus 3. The question is, what is the other factor? And the factor is x plus 3. So x over x plus 3 over x minus 1 x plus 3 minus squared plus 3. So we've got this. Now we could solve. So that comes to, I'm not going to go step by step, I'm going to assume that you know how to do this. That comes to 3 x minus 1 over x minus 1 x plus 3. We've got x minus 1 on the top, x minus 1 on the bottom. Simplify. And the answer is B. So that's number 24 completed. Question number 25. In a type of fruit fly, the brown body color allele is dominant to the black body color allele. A male fruit fly heterozygous for body color and a female fruit fly heterozygous for body color were allowed to mate, producing offspring. What is the ratio in its simplest form of maximum number of genotypes in the offspring to the maximum number of phenotypes in the offspring? So we need to draw a Punnett square. So big B, little b, big B, little b. The reason why I'm doing this is that they're both heterozygous. Heterozygous meaning that they each have both alleles. So this is B, 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 B. So there are 3 maximum number of genotypes that could be produced. Big B, big B, big B, little b, and little b, little b. There will be a maximum number of 2 phenotypes, one being brown, one being black. So therefore, the ratio would be 3 to 2, which is C. And that is question number 25. Question number 26. Xenon gas reacts with fluorine gas to form gaseous xenon hexafluoride. At high temperature and pressure, the overall energy change is minus 330 kilojoules per mole. Under these conditions, the fluorine-fluorine bond energy of the fluorine gas is 158 kilojoules per mole. What is the xenon-fluorine bond energy? So, straight away, you need to think of enthalpy change is equal to the sum of enthalpy of reactants minus the sum of the enthalpy products. So we know the enthalpy change is minus 330, which is equal to, so we know the reactants, which is 158, and it says that the product formed is xenon hexafluoride. Okay, so let's quickly write an equation because just to double check. So Xe plus 3F2, because fluorine is diatomic, goes to XeF6. So there are 3 diatomic fluorine, so we're going to do 3158 minus X. Now we want to work out X. X is equal to 3158 plus 330, which is equal to 408. Well, I mean 804 kilojoule per mole. Now, this is the trick. You need to divide 804 4 by 6 because you want to work out one bond enthalpy, not 6 bond enthalpies. So that comes to 134. And that's your answer, 134. So your answer is C, and that's number 26 completed. Question number 27. The radioactive isotope carbon-14 is found in living material in small quantities. There are approximately 1,000 carbon-14 atoms for every 10 to the 15 carbon-12 atoms. Whilst the material is still living, this ratio remains constant because even though the carbon-14 is decaying, it is being constantly replenished. When the material dies, the carbon-14 decays and is not replaced. The half-life of carbon-14 is about 6,000 years. In a bone, the ratio of carbon-14 to carbon-12 is found to be 100 to 10 to the 15. Which of the following is the closest estimate of the age of the bone? So, straight away, I would write a ratio of what the carbon-14 to carbon-12 atoms is when it is at the beginning, initially. So that would be 1,000 to 10 to 15. Using that information, we're going to use the half-life to work out and estimate the age of the bone by halving the ratio each time. So 0 years is 1,000, 6,000 years is 500, 12,000 years is 250, 18,000 years is 125, and 24,000 years is 65. From this, we can see that the bone is between 18 and 24,000 years old. So the only possible option available for the answer is E, 20,000 years. That's question number 27 completed.